Hello everyone, I am Arshal Haridharapurekar and today I will be presenting on differentiated service modeling quality of services as a part of our computer network and security course under the guidance of the Suvarna Kadamma. Here is my outline of my presentation. We will begin with the introduction to quality of services, followed by the quality of services model, and then we will discuss about the DiffServ in detail, covering its architecture, components, advantages, and limitations. And then finally, we will go to introduction to QoS. QoS stands for the quality of services, refers to the ability of the network to provide better services to select network traffic over various economies. The key aims are the bandwidth management, low latency, reduce packet loss. The importance of the QoS in the networking are ensuring smooth performance for real-time applications like VoIP and video streaming, and help manage bandwidth efficiently and reduce packet loss, latency, and jitter. There are two types of quality of services model. The first one is the DiffServ and the second one is the DiffServ. DiffServ is a part of the fine-grained approach in which provides QoS to individual application or flow, and the DiffServ is a part of the coarse-grained approach in which provide QoS to large classes of data or aggregated traffic. The first feature is of the DiffServ and the second feature is of the DiffServ. Limitation of the DiffServ are as follows. First one is the scalability. Router needs to be maintained states for each flow, which is impracticable for large network. The second one is the lack of flexible service model. Itself has only two classes. Wants to provide more qualitative services classes. Want to provide relative services descriptions. The third one is the singling overhead. Many applications and users may only want to specify a more qualitative notions of services. Then we will go to the introduction to DiffServ. The first one is the traffic management at network edge. Handling at network edge due to the slower links, similar to shortage mailed before delivery. Packet of prioritization. Packet are labeled with the prioritized tags. Efficient, efficient core network handling. Use labels for traffic management. Fewer labels ensure fast processing. Fourth, flexible frameworks. Define traffic forward rules. Service providers customize quality of services levels. Fifth one is the scalability. Keep core network simple and efficiently, and manage group of traffic but support detailed control if needed. As you can see in the image, there are two type of routers: core router and edge router. The PC will send the message to the edge router, and it will pass through the edge as well as morely at the edge router and then core router, and it will be received by the receiver. Then we will go to the DiffServ architecture. In DiffServ architecture, there are the two routers, edge routers and core routers. Blue one are the edge routers, and the yellow one are the core routers. In the edge router, per flow traffic management is happening. Marks package as in profile and out profile. In core routers, per class traffic management is happened. Buffer and scheduling based on marking at edge. Prefer giving to in profile packets over out of profile packets. As you can see in the given picture, there are three PCs. There are almost three edge routers, and remaining are the core routers. The marking is happen at the edge router, and the scheduling is happen at the core routers. Many may be desirable to limit traffic injection rate of some classes. User declare traffic profiles. Traffic meters shapings is if no configuration. In the diff architecture, there are the classifiers, there are the makers, there are the shapers and droppers, and the packet will go through all the blocks. The classification help us to select a package in a traffic stream based on the content of some portions of the packet headers. Metering help us to check whether the traffic falls within the negotiation profile. Marking will help us to mark packets to a particular DS behavior aggregations. The shaper and dropper help us to delay if necessary and then forward or discard the packet. It means that the packet first of all go through the classifiers, then some of the packet will go through the meters, some of the packet will go to the meters, and some of the packet will go to the markers, and the
marking packets are directly go to the shaper and dropper, and untrusted marking packets will go to the meters, and and they they both the meters and the markers package will go to the shapers and droppers. And there is a one certain agreement, we can say the agreement. If the agreement is uh, the agreement is verified by the packet, it will go forward. If the agreement is not verified by the packet, it will drop. This is the main architecture of the DiffServ. So differentiated service code point. Differentiated service code point is a means of classifying and managing network traffic and of providing quality of services in modern layer 3 IP network. It uses a 6-bit differentiated service find in the IP headers for the purpose of packet classification. So in the IPv4 first three are the prioritized block, the third to six are the one hot field for delay, cost, throughput, and reliability block, and the last one is a must be zero block. But in the DS field, the from 0 to 5th are the DSCP block, and the 6 to 7 are the current used block. When the packet will come to the DSCP field IP, it will go to the traffic class, and if the packet is successfully agreed the traffic class, it will go to the high priority traffic. It is not agree with the traffic class, it will go to the low priority traffics. The per hop behavior. Per hop behavior define how packets are handling at each hop in the network based on the differentiate service code point value. There are mainly three PHPs. First one is the EF, second one is the AF, and third one is the BF. EF stands for the expected forward, ensure low latency and low jitters, used for the real-time application like view, IP, and video configuration, and typically assign DHCP value at 46, which is 101110. AF stands for assured forwarding, provide different levels of priorities for traffic divided into four classes: AF1, AF2, AF3, AF4, each with three drop probabilities. Ensure better service than best effort but without absolute grandness. The third one is BF stands for best effort, default behavior, no prioritization. All traffic is treated equally with no guarantees on delay or packet loss. DHCP value is 0, which is 000000. As you can see the picture in which the 6-bit pattern is given XYZ AB0. XYZ is the classes, which is 001 is class 1, 010 is class 2, 011 is class 3, and 100 is class 4. And AB is a drop precedence. 01 is low, 10 is medium, and 11 is high. Based on this, the the table is created. Then we will go to the DiffServ and the IntServ differentiations. The management unit in the DiffServ is class and the IntServ is low. Routing capability in the DiffServ is edge and core. IntServ is all-in-one. Defined in the standards, DiffServ is a forward behavior. IntServ is a service type. Graduate requirement in IntServ is provisions, and in DiffServ is provision and IntServ is reservations. Work region in DiffServ is a domain, and IntServ is an end-to-end. Advantages of DiffServs are mainly the scalability, no dynamic changes of state cell communication between routers can be deployed for a specific domain independently. Second is the simple, relatively low number of states using a stateless approach, minimize the need of nodes to reminder anything about flow. The third one is a divide load and router edge versus core edge routers. A few strong and expensive one core routers, a lot of simple and cheap ones, no simple. Limitations of the DiffServ are the no absolute QoS guarantees, potential for misconfigurations, depends on end-to-end policies, and possibility of traffic saturations. These are the main limitations of the DiffServ. Real-world applications in the DiffServ are the voice over IPs, the video configuration and streaming, the online gaming, and the cloud service and data centers. Thank you.